Welcome to How AI Happens, a podcast where experts explain their work at the cutting edge of artificial intelligence. You'll hear from AI researchers, data scientists, and machine learning engineers as they get technical about the most exciting developments in their field and the challenges they're facing along the way. I'm your host, Rob Stevenson, and we're about to learn how AI happens. Joining me here today on How AI Happens is a man who contains multitudes. I think it's fair to say. He has served a variety of roles across the tech space, such as being the principal data scientist and executive advisor over at Booz Allen Hamilton. He was a professor of astrophysics and computational science over at George Mason University. Currently, he's an advisory board member over at DataPrime. That's only a tiny piece of the picture here. I better bring him in before I insult him anymore by introducing him poorly. Dr. Kirk Borne, welcome to the podcast. How the heck are you today?
Good, Rob. Great to be here.
When I was going through your curriculum vitae and just kind of looking at some of the titles you've had, my favorite was VP of Technology / astronomer, which I just love that you did both. And in addition to leading an entire department, you also spent a good amount of time looking through a telescope and doing math, I imagine. Could you tell me a little bit about just your multivariate background? Maybe we'll start with the astrophysics and astronomy, because it feels like that was kind of where you spent a big chunk of your career.
Yes, thanks. So the first half of my career, I guess I would say, was the thing that I always wanted to do since the childhood, which is be an astronomer, be an astrophysicist. But that was always driven by the computational things I could do, building models like galaxies is what I did. I also, in my early days, built models of stars and other kinds of things. So it was all about modeling. But what was I modeling? I was modeling data that we obtained from telescopes. Okay, so you might say it was all about data and modeling all the time. And so my first 20 years was not in any of the jobs you just mentioned. My first 20 years was working on various NASA projects. So I worked with the Hubble Space Telescope for 10 years. I was the Data Archive Project scientist for that. Again, data. And then beyond that, I did another 10 years at the NASA Goddard Space Flight Center, where I was managing a team of people working at what's called the Space Science Data Operations Office, where we basically manage data sets coming from NASA astronomy satellites. And so I tell people I did data by day in my day job and data by night as an astronomer. But that's a bit of a misnomer, because telescopes nowadays are all remotely operated. A lot of them are in space. I mean, I did do some looking through telescopes when I was younger, but that very little of that actually happens in a professional astronomer's life. But I did have an opportunity to do some of that when I was younger. So I was always interested in modeling complex systems using data, which tells us about the system. Then how can we build a model? And what is a model? It's a representation of the thing so that you can understand it. You can test it. For example, I can't test a galaxy. I can't go out to a galaxy and kick it and see how it responds, but I can build a model of a galaxy and crash it into another galaxy and see how it responds. And there's actually things in the universe that do that. Galaxies crash into one another. So for me, modeling data, computational and data science went hand in hand all those years doing astronomy. And then about 20 years ago, I started migrating more and more to other disciplines, because I saw that the big data sets we were collecting in astronomy were nothing compared to all the big, huge data sets we were seeing in business and government and healthcare and cybersecurity and all these other domains. I mean, consumer data, et cetera. And so I just found it more exciting to take the skills I learned as a computational scientist, as a data modeler, as a data scientist, and bring that into a broader domain. Because what it was really satisfying within me was a deeper thing. Besides always wanting to be an astronomer, I always felt motivated to be an educator. I always wanted to train and teach people. And I feel like I can do that all the time now. It's basically training, education, mentoring all the time for me now in this role as a data scientist. So the advisory roles give me that opportunity, but also I'm very active on social media. And I think of Twitter as my micro education platform. Okay. So I'm constantly tweeting out things which I want to just sort of teach people, train people, inform people, help build literacy around data and literacy around AI as well.
I want to ask you a question about data quickly here before we get on to some of the other stuff, but it's interesting that you say there was way more data being collected and perhaps synthesized in the business and consumer space than there was in astrophysics. That seems strange to me, because in astronomy and astrophysics, you have, like you said, these telescopes in space, remote operated, probably constantly operating and looking out into infinity, right? How is it possible that there's more data coming from the on-Earth world than there is looking out into the endless depths of the universe?
Well, let me modify slightly my statement. So in recent years, we're building huge telescopes on the ground, not in space, and they're doing what we call large surveys of the sky. So the data sets coming from these large telescopes on the ground, these large surveys all across the sky, the full sky surveys of the stars, the galaxies, everything there. Those are massive data sets. Those are very large, hundreds of petabytes. So they are definitely larger than a lot of things. But in sort of early days, sort of individual astronomers would just collect a small data set at a telescope and analyze a particular question, like you're doing an experiment in a lab, right? Someone who's doing chemistry experiments in a lab, they don't have all chemistry data from the history of chemistry that they're working with. They're just working with that particular experimental data set. So that's one thing. But the other thing was when I was working at NASA on space missions, people don't realize this, but the bandwidth maybe changed and improved a lot in the last decades or so. But in those early years, the bandwidth of transmissions from space was very low bandwidth. For example, when we had these flyby missions like of Jupiter and Saturn and Pluto, it would take months to transfer the data back to Earth because the bandwidth from those transmission systems are very low. And so even the Hubble Space Telescope, for a while there, people thought, wow, Hubble's like producing massive quantities of data. But the entire data set of Hubble, like the first 10 years of Hubble data could probably fit on my hard drive, on my laptop, right? Because even though the data is phenomenal, high resolution and beautiful and just super high quality, the actual volume of it is actually relatively low. Now, again, in recent years, telescopes and communication systems and satellites, et cetera, have all improved dramatically. And so it's not strictly a true statement now. But it was true back in those days that, that a gigabyte of data was like enormous, right? But of course, nowadays you have a gigabyte on your phone, right? You probably have 100 gigabytes on your phone. So it's like what we called large back then is hardly what we call large nowadays. Space is so big, yeah, you would think you could have enormous amounts of data. And that's what these large ground-based telescopes are trying to do. They're collecting data on like literally hundreds of billions of objects in space. So we are collecting massive quantities of data. And the reason ground-based makes a difference is because you have all the wired internet, right? You don't have wires into satellites orbiting around Earth, right? So the transmission volume, 5G networks on Earth are very localized. So the best way you get high-speed data on Earth is through wires, the internet, the wired internet. Okay, so we can do that from the ground. We can collect massive quantities. But so when there's satellites in space, it's not just astronomy. It's weather satellites, it's remote sensing satellites, it's any kind of communication satellites. They're getting better and stronger over the years, like I said. But in the early days, it was very limited.
If you'll pardon the pun, do you miss working in that space?
The space. Oh, boy.
Sorry.
Oh, boy. Some days I do. I mean, certainly, ever since I was a child, I wanted to be an astronomer. I mean, I got a colorful picture book of astronomy when I was 9 years old, and I just fell in love with it. I mean, it wasn't anything technical, but it was just, I just said, I just want to know how this works. I want to understand this. And fortunately, I had the aptitudes for math and physics and science. And we actually had a programming capability in my high school. And this is, we're talking like 50 years ago. I'm dating myself now, but we actually had a link up with a computer at the local university through our high school, which was very rare in those days. And so all those things that inspired me, then I could actually fulfill in a career as an astronomer. But what I do now, in some sense, like it taps into that other dimension that I mentioned about what really gives me passion in life, and that's teaching and training people and seeing the look on people's face when I can teach them something that they didn't really fully understand before. And so that, for me, is almost like fulfilling the second half of what I always wanted to do. I
see. And you've continued that. You've continued education, even though you left George Mason's a few years back. But you have this new project that you are working on, which is sort of a more egalitarian approach to AI education. Is that fair to say?
Yes, we call it blue collar AI. So in fact, after I left George Mason, I've even had adjunct faculty positions at a couple of other universities. What an adjunct means is they're not a full-time faculty. I'm just paid to teach a class. Okay, so it's not really a salary job. You just get a stipend for teaching a class. So I kept my foot in the water, so to speak. But this blue collar AI thing is something that was generated from the DataPrime company, the startup where I've been working for the last couple of years. So DataPrime has worked with Miami-Dade College in Miami. It's probably one of the largest community colleges in America. I don't remember the number. It's like 80,000 students or some massively large number of students, all from the local area. I guess you call it sort of a low to mid income area. And so the community that they're serving are not necessarily, high income people. They're not necessarily people who are going to go to university or Harvard, those kind of people. They're just your standard people who are maintaining the local economy and all walks of life, all types of different jobs. And since data is everywhere, digital transformation is everywhere, and AI is enabling and empowering people to do business better and faster, we figured, well, even these people who may not think that they want to learn the math and the science don't necessarily need to learn the math and the science, but they need to know what AI is, what automation is. And primarily, the one thing that I like to tell people is it's helping people get over the fear of it. I mean, there's so much fear of it. I mean, not just in those people, it's even in executives and businesses. They think this AI is going to take over their business. It's going to remove their decision-making authority. The workers in the business are afraid it's going to take their jobs away. The middle managers have been afraid for a while now, because as soon as data scientists came along and they discovered all these insights from data, the data scientists actually have a seat at the table with the executives now in terms of like, what is the data informing us about our market, about our business, about our consumers? So the middle manager said, where's my role here? I mean, the people who report to me are now talking directly to my boss. Where do I fit in? So there's like fear all over the place. And so I think I want to reduce that fear by what I teach people, and that it is basically a literacy about what it is, how it amplifies and assists you in your work and helps automate certain aspects of your work, but it's not really taking your work away. It's just making it better and more efficient or more effective. I like to tell people there's a difference between efficiency and effectiveness, and both of those are sped up, right? Efficiency is the speed at which you get something done, and effective means the amount that you can get done.
So you have educated on this topic now at both ends of the academic spectrum, let's call it, right? If you look at like the individuals maybe pursuing PhDs, fantastically highly trained, maybe have already like worked in the private sector, then come back to school, and now blue collar AI, like these are not technical people traditionally, right? What made you want to do both? What made you want to move away from like the PhD type students and work with folks who don't have as much access to tech?
Well, again, it goes back to that sort of deep passion I've always had. Even when I was in high school, elementary school, not so much elementary, high school, even in college, I was tutoring and mentoring people who were, maybe challenged a little bit. I remember where I had a short-term 2-year position as an instructor at University of Michigan after I got my PhD. And I was teaching introductory astronomy. And occasionally there would be like members of the football team who needed a little extra assistance and passing their science course, and that's fine. And so I was occasionally drafted, so to speak, by the football department, but the athletic department, I should say, to mentor some of these young men. And in fact, even young women. I mean, people on the baseball team, softball team, basketball, swimming team, things like that. And so I found pleasure in helping people understand complicated things. I mean, it's a victory. It's like a win-win. That's what I liked about it. I mean, I felt like I succeeded in achieving something, and the person who finally got it understood the concept, this complex concept. It was very pleased with themselves. Okay, so there's a certain sort of mutual value that's exchanged there. When you're working with graduate students, it's somewhat different because you're trying to push them along to help them to get to that point where they can be an independent researcher and come up with their own ideas and do their own research. And you work with them and mentor them and move them in that direction. But at the end of the day, the real victory is their victory. I mean, I contribute, but the real victory is their victory when they achieve that doctorate degree. That's reassuring to me and pleasing to me in another way that I was able to help this person get there, but it's really their work that's being celebrated. So there's a variety of different kind of motivations that go on when you're doing things like this.
What are your hopes for the students in the blue collar AI course? At the end of the course, how have they changed?
Well, for one thing, it's really about becoming AI literate, most of all, not necessarily AI fluent. I mean, I think there's a sort of a difference between, we use that terminology even in data literacy versus data fluency. So if I can refer to data for a second, then you can sort of easily see what I mean by AI literacy and AI fluency. So in data literacy, it starts with people recognizing data when they see it. Okay, so for example, when you are using your smartphone, almost everybody in the world uses a smartphone. I see my grandkids on all day long. They're on their iPads and their smartphones. Can't get them off. So everyone is generating data. Okay, when you visit a site, when you click on something, when you search for something, you're generating data on the other end. They know what your interests are, what your intentions are, what kind of things you're doing. So they're using your data. They're creating value from data. They're making money from data. And I tell people, you are a generator and user of data when you're on that device. So why don't you get involved with this economy? Why don't you make your career and make money out of this? So AI literacy is the same sort of thing. You recognize where AI is and see what it is. And it's not a scary thing any more than data is not a scary thing. Some people come to me and think data is a 4-letter word, and I teach them that it's not a 4-letter word. And so some people think of it as a scary thing, but I'm trying to teach them that it's not a scary thing. And so AI literacy and AI fluency are, again, as the parallel to data literacy and fluency. Literacy starts with understanding what when you see it and knowing what it is when you see it. Fluency is now you can work with it. You can actually apply it in your job. You can do something with it. You can, create value from it either for yourself, your business, your boss, whatever. And so AI fluency and AI literacy is sort of the same thing. So what we're looking for in this blue collar program is first to have people just aware of where AI exists. All right. I mean, so the easy for people to grasp is actually not simple. A self-driving car. Okay. Okay. So people can understand a self-driving car. How is that car doing that? Well, it's got cameras, it's got sensors, it's got different kinds of things that helps it to understand where the road is going. What does the stop sign say? What does the speed limit say? What does that school zone sign mean? I mean, slow down. How far away is that car in front of me? Is it moving faster than me, slower than me, or at the same speed as me? So there's LiDAR, there's radar, there's cameras. And so we start talking about all those data collections and how the AI is learning how to read the sign, to read the condition of the road or the weather conditions, or read the sort of the location and speeds of the vehicles around you, et cetera, et cetera, et cetera. So it's a complex, very complex problem, but people can understand the concept of a self-driving car. If I talk about a digital twin, which is a computer copy of a manufacturing plant, that gets a little hard for people to visualize. What is a digital twin of a manufacturing plant? Okay. So that's a little bit more complex. So we start with something which is also complex, but which people can understand as a car. And so we start building this literacy around that is recognizing it, understanding it, knowing what it is, knowing that it uses data, and what is it doing with data? It's finding patterns in data. If you're reading a stop sign or reading a speed limit sign, there's a pattern there. The digits on the sign to a camera is just black and white pixels. It's just black and white pixels, but the AI algorithm can interpret that as a number, and that number refers to a speed limit, which so it understands it's not just a number, but what is the context and meaning of the number. It's not just a number; it's a number with some kind of meaning that's informing you about something, and that's what AI is all about. He's giving you insights that inform actions and decisions. And so once people start grasping those ideas that it's about informing actions and decisions, and they can start to see, oh, this can actually help me do my job better, right? I can use this AI to help scan through my emails to find the most important emails. I can even use an optical scanner to scan through the mail that comes into my office to identify which mail is coming from a customer, versus which one is probably just some marketing mail or something. And so these kind of things help people in their jobs, regardless of their jobs. I mean, so there's different types of ways that automation and digital transformation is changing a lot of jobs in the world. I mean, not just the high-end professional job, so to speak, but the blue-collar job, and by which I mean people that don't necessarily need a 4-year college degree or an advanced degree.
So these are the people that have traditionally been kind of left out, right, of the development of this tech, because this tech is being developed in such like highfalutin places, right? In very forward-thinking businesses with lots of money and in research facilities and academia, et cetera. What do you think is the risk of these individuals being left out of the development of this tech?
I think the risk is similar to the previous industrial revolutions. Let me just put it that way. All right. So people refer to what we're going through now as the fourth industrial revolution, right? So the first was the steam power revolution, right? So people went from sort of manual labor on the farm to having a steam engine power different kinds of things. And then the second industrial revolution was when electricity was introduced into industry and certainly changed the way a lot of things were done. And then the third industrial revolution was really the computer revolution 50-something years ago. Essentially back in the days, back in the early days of computing, a very famous guy said he couldn't see the need for more than 3 computers in the world. And then this sort of famous guy called Bill Gates once, even the guy who invented the PC, basically said he couldn't imagine anyone needing more than 640 kilobytes.
Right.
Well, of course, I got a terabyte disk drive sitting right in front of me, right?
Yeah, aged like milk.
So the computer revolution is different. I mean, it was definitely industrial revolution, the computerizing of all kinds of business operations, et cetera. And so the current industrial revolution is all about the big data flows, the AI, the machine learning, the interconnectivity among different things. So think of something as simple as someone operating a cash register, right? So a cash register basically is doing computations on things that you buy, right? It adds it up, it calculates the tax. Okay, and even understanding that kind of aspect of computing, as relatively simple as you might think it is, is a valuable thing. I remember hiring a person once who had very little capability in what I would call traditional computer technology when I was a manager at NASA. But this guy had really good organization skills, I could tell, because he was a photographer and he did a lot of field work in photography, and he organized his photograph collections in very smart ways. And I said, this guy actually has an aptitude for understanding, sorting and arranging and collecting things, which is what data is about: organizing, collecting, sorting, finding the patterns in the data. And so it turned out he was one of my most successful hires. I basically hired him at the lowest end of the salary scale that I was allowed by law to hire someone. And they ended up pretty much near the high end by the time he moved on. And in fact, he moved on to actually have a chief technology officer job at a university. I mean, I felt like that was quite a success story for me. A guy who basically came in just looking for any kind of job, hired him as a data clerk, the lowest ranking job we had. And the guy moved up in his career to where he became an officer at a university. And that was one of my favorite, my best success stories in life. And this is the kind of thing we want. We want people just to feel comfortable doing things that people are really good at. Sorting, kids, kindergartners, really good at sorting things, recognizing patterns in things, being able to, sort of manipulate things. And that brings value to business. If you can organize your customers into different customer segments, marketing segments. I've heard stories at conferences, people that were just basically clerks, so to speak. Again, they were not the technology people. They weren't the database people. They weren't the programmers. They weren't the Ph.D. scientists. They saw some pattern in the customer data and actually introduced the idea to an upper manager who had the power and executive authority to do something, and they did something and actually made a lot of money for the company. And it was just started with someone just saying, hey, I have the power to do something. And so the way that started, actually the way that works in the real world, is you get empowered from the culture of the business. So there's different ways that I've heard of this. One is I've heard a culture of experimentation, right? Test to see, is this data really telling me that this customer will buy this product if I recommend it to them? I mean, so we have recommender engines, right? So people can test different things. I mean, there's a famous casino in Las Vegas which expresses this another way. So culture of experimentation is one way of expressing it. This casino calls it another way. Their culture says, test or be fired. Well, there's an ultimatum to you if you work there: test or be fired. So what are they testing? They're testing what is it that the customer wants. Okay, think of a casino. I mean, people are in there, they're going to shows, they're playing the slot machines, they're playing the game tables, having drinks, do all kinds of things, right? So find out what the customer likes. What's going to keep them there? Test or be fired.
And data everywhere also, right? You're like in this controlled environment. You're recording everything.
Oh, you talk about a lot of data. There's a place that has it. And the third way that I've also heard and I found very successful way to describe this concept of experimentation or test or be fired, as a CEO of an airline once told his people, if you see something, say something. I mean, that was his motto. So if you see something in the data, something about the customer, something that customers like, something customers are doing, just say something, whether it's your job or not. Okay, no matter who you are in the business, if you see something, say something. And so he empowered people who were not the database engineer. They weren't the data scientists. They weren't the AI professional. They were just someone who understood what he meant, right? So if I see a pattern, I see a trend, I see something in the data, I should be empowered to say something. And he told stories in a conference keynote that I heard once from this guy, and they really inspired me. I mean, the fact that this guy was able to feel comfortable as the CEO of the business to empower all of his people, no matter who they are, to speak up when they see patterns in data that could be informative for insights. And so that's what we're trying to achieve with this blue collar AI, is for people to feel comfortable with it, to see where it can bring benefits to their business. Even if they aren't the one to implement it, if they're doing something in their job, they could go to their boss and say, hey, I'm aware of this new automation tool that can help me process these invoices or process these emails or whatever. I mean, being aware of and knowledgeable of the ability of automation and AI to improve their business, even if they're not the one to implement it. That's what was the value of some of the stories that I've heard from these executives, is the people who suggested these things weren't the ones who implemented it. I mean, they didn't know how to implement it, but they were able to see something and say something. And that's really made a huge difference, both in that business itself and probably in the life of those employees, I'm sure.
This approach to education, it reminds me a little bit of Carl Sagan or Richard Feynman, these individuals who really understood that if you couldn't understand something really simply, then probably you didn't understand it well enough yourself. Yeah,
there's that famous expression, if you can't explain it to your grandmother, you really don't understand it, right? Or if you can't explain it to a third grader, you really don't understand it.
You worked with Richard Feynman briefly, yes?
I wouldn't say worked. I took a class from him. And I actually talked with him separately on some occasions when I was at grad school at Caltech, because he was a professor there. And there's a book that he wrote called "Surely You're Joking, Mr. Feynman." And I think there's even a sequel, part 2. I read that book, and after I left graduate school, I knew him personally at grad school. I read this book afterwards. It was a perfect characterization of this guy. He was just a jokester, a brilliant human being, and he knew how to play jokes on people. And he primarily played jokes on people who were like arrogant, people who were too smart for their britches, as we used to say. So my funny story with him was, I was working in the physics building on my Ph.D. And I say the physics building because the astronomy building was separate. And anyway, but the supercomputer I was using was there. And one day the fire alarm goes off, and I don't know if it's just a test or a real fire. So I leave the building and I go outside the building, and I'm sitting out on the little brick bench that's in front of the building, waiting for the fire trucks to come, and hear the fire trucks down the road. They're on their way, waiting to see what happens. And while I'm sitting there, I see Richard Feynman down the street running towards the building. Okay. So it's the end of the day. So he was obviously running from the faculty parking lot. He was probably leaving for the day, and he's running towards the building, and he sits down next to me. And I was just a young guy. I mean, literally just a totally young student. And here's the world famous guy, Nobel Prize winner, worked on the Manhattan Project, sitting talking to me. Okay. And he sits down totally out of breath. He's huffing and puffing, trying to catch his breath. And he says to me, he says, "I really wanted to see the fire trucks." I said, "I was going home, but I want to see the fire trucks." I mean, it's just like a big kid.
Like a 12-year-old boy. Like, I can't miss the firemen.
and that was just him. And that was just him. I mean, he sort of never lost that sort of childhood curiosity. And I think that's the other thing I like to tell people is, what are we all born with? We're all born with that curiosity. We're natural born scientists. I always tell people children are natural born scientists. All right. Unfortunately, our education system drums that out of kids, right? They start asking a lot of questions and it gets annoying, right? Why? It gets to be annoying. I get it. But on the other hand, we're all natural born scientists. We're all naturally curious. And so people with this blue collar AI and even sort of blue collar data science, I would say, is blue collar machine learning, whatever you want to call it. It's all about pattern recognition, right? Asking questions. Why is that? What is this? Why is it doing that? What does this mean? I mean, so we're naturally born asking questions. So when you see a pattern in the data trend, like, why are people who are buying this product also buying that product at the same time? Maybe we can create a marketing campaign around this. So now we have recommender engines everywhere, right? I mean, not just in products. I mean, even if I go read a journal article, it recommends similar articles for me to read. So recommenders are all over the place. What is that? That's an AI, right? So as soon as people realize, well, what you naturally do, like, I read this or I see that or I buy this, I say to myself, well, what else is like this? I like this. What else is like this? Well, that's what an AI is answering. It's answering that question for you.
Yeah, and it's an important call out that whether you have the literacy or not, it's affecting you, right? Its action is being taken upon you, or by the tools you use, your data is being collected and served back to you in ways. The data collection piece I wanted to ask you about, because for so long, people have been paying for internet services with their data, basically, right? As long as you click the terms of service button, I agree, and we collect this data on you, and now these things stay free, right? Do you foresee a time when people can kind of take the power back on their own data, when it's like, look, I expect to be compensated for the use of my data because I know that these companies are taking it, selling it to advertisers, or taking it and using it to design better products? Is that a realistic outcome for personal data?
Yes, it absolutely is. That's one of the definitions of what people call Web 3. So just as a clarification, back in the old days, we talked about Web 3.0 or Internet 3.0, and that was more about the semantic web, the semantic ontology-based web. And if you don't know what that is, that's fine. But you can look it up if you want. But Web 3 is a different concept, which is you now take ownership of your own data. And there are companies out there which are moving in this direction. I know a company called Jennyco, so Jenny, as in the name Jenny, Jennyco, is doing that with healthcare data. So you basically give companies permission to use your health data, whether it's designing products or whatever, and you get some kind of small compensation for this. Okay, I know ad companies have been surviving, so to speak, through cookies. Cookies are going to go away, which are basically these trackers on the internet knowing where you are and where you're going. So that's your data that's being monetized by these companies. Right now, I know that you like this. I'm going to recommend products to you like this. Essentially targeted marketing. So the more targeted your marketing is, the more chances are you're going to get someone to buy the product, right? And instead of just sending the ad to just every random person on earth. And so the more you can get control and ownership of that data, then you can get some share of the data. Because even though it may not be you that buys the product. You are of a certain demographic and your education background.
You're a buyer persona. You're a profile.
Skills,
yes.
Your profile, whatever that profile might be. And I don't mean that in a negative way, like things that we shouldn't be basing decisions on, but things like what's your education level? What kind of technical field do you work in? You know, what part of the country you live in? That makes a difference, right? I'm not going to sell snowshoes to someone in Miami, right? Okay. But anyway, if you're a sports enthusiast, then maybe you would want to buy sports products. Okay. So these types of things, they learn from you and then offer products to other people. And if they learn that from your data, if you get some small percentage of that data monetization that they're acquiring, they're monetizing your data, if you get a small percentage of that, then that's basically Web3. And so I see this coming. I mean, there's companies, like I said, just a company called Genico and some other companies that are working in this direction. There's this company called Alchemy Exchange, which is doing this with programmatic advertising data. And so I just look around and see these things starting to happen. And I think there is, of course, this move now that basically cookies will be outlawed starting this summer or next summer. I mean, so companies can no longer use those tracking cookies to follow you around the internet and know who you are and what you're doing all the time. Okay. It was sort of scary that we ever allowed that in the first place. I mean, originally cookies were just basically session trackers, right? So if I'm on this web page and I spend all this time doing something, searching through products, and then I have to go away for a while, and then I come back to the computer, do I have to start from scratch, all that work I did? Well, the session cookie kept track of where I was so I could just resume.
Right. Keep you logged into places. If you've ever deleted your cookies accidentally, it's a painful thing to keep browsing afterwards.
Yeah, so we used these at NASA back in the day when people were browsing our data sets and they were looking through all kinds of data to find specific data on specific things they were interested in space. We wanted to keep track of that so they wouldn't have to redo all those searches all over again the next time they come to our site. I mean, it's just a terrible efficiency waste, a time waster, okay, to have to do it all over again. But they went beyond session cookies to basically these tracking cookies. And they now know when you go to Amazon or you go to eBay or you go to MSNBC.com, it's still you, okay? So this person is looking at sports scores. They're buying sports products. They just bought some sports shoes and they're looking at reviews of basketballs. Okay, we now know a lot about you from all these different websites you visited. And so those kind of things are getting deprecated, is the word I would say, that is used a lot less and eventually made illegal, those kind of tracking cookies. So there's got to be a way now that companies can continue to get value of understanding who you are. Because, I don't thoroughly object to these kinds of things. So I would rather have things marketed to me that I'm interested in, not just random stuff.
Right. And that's like, no one hates an irrelevant ad, basically, right? Because like, okay, I'm looking for this anyway,
yeah.
but it's not always as mundane as, I live in Miami, why am I getting skis? It's like, I have this zip code, why am I being denied a bank loan? Right? That is the challenge.
Yeah, that is the scary part of it, right?
So
exactly.
Is that more why the government needs to be involved? It can't just be, people's data is being used to send them better sporting goods. Like, what is the government's incentive to be involved here?
I think it's all of the above. I mean, there's such a huge push towards data privacy and going after abusers of data privacy. And I think in some sense, more and more people realizing that your health data, your consumer data, your purchase data, these things they're private data, so to speak. So there are definitely the ethical issues of using something like, for example, your zip code, or your gender or your race or something to deny you a loan. I mean, those things are illegal, obviously. It's not necessarily illegal that you're offering me skis when I live in North Dakota. I mean, it's sort of obvious. I might need skis or snowshoes if I live in North Dakota. But at the same time, like you say, it feels kind of creepy sometimes.
It seems like, at least in the United States, it kind of stems back to this like expectation of privacy, right? Almost like a constitutional expectation that like you have your own kingdom, you have your own like home and your own space, and then like people can't trespass on it, and like the police can't come in unless they have a warrant. That kind of attitude. Do you think this is just the extension of that into the digital realm?
Yes. And I think actually Europe has really taken the lead on the general data privacy regulations, the GDPR. California has really taken a big stand on the data privacy. So it is a worldwide phenomenon. And certainly there's a lot of strength in the Western countries, not so much elsewhere. I can say it that way. I mean, so I think we have a lot more concern about the ethical uses of AI and data in some countries than in other countries. I'll just leave it at that. So some other countries exploit. I mean, we know all about different kinds of hackers and different regimes in parts of the world who are perfectly fine hacking into your systems and stealing your data and holding it ransom. I mean, yeah, there's scammers and spammers everywhere, but I think there's almost like a government-sponsored, state-sponsored behaviors of that sort in some places in the world. And so we are definitely much more conscious of doing the right thing. Of course, there will always be, like I said, there's always going to be criminals who are going to do the wrong thing. But I mean, in general, we have expectations that the right thing will be done.
Well, Kirk, I feel like we could keep going all day. There's so much more I want to speak with you about. I guess I'll just have to have you back on at some point. But for now, I would just say thank you so much for being with me and sharing your journey and experience with me. I've loved chatting with you today.
Thank you, Rob. It was great.
How AI Happens is brought to you by Sama. Sama provides accurate data for ambitious AI. Specializing in image, video, and sensor data annotation and validation for machine learning algorithms in industries such as transportation, retail, e-commerce, media, medtech, robotics, and agriculture. For more information, head to sama.com.